Chapter 1: The Post-Glacial Flooding Hypothesis. In the first book of this trilogy, The Post-Glacial Flooding Hypothesis, we looked at the new mathematical models that allowed us to calculate the amount of water that was released during and after the last glacial maximum just over 10,000 years ago. These models showed us that a minimum of 8.42 quadrillion tons of water was released on the UK at the end of the last ice age. This is equivalent of 98,425 inches of rain, falling on every inch of Britain's landmass, or the same as 1 inch of rain steadily falling every day for the next 270 years. So how would that affect the landscape? The worst known flooding in British history occurred in 1947 when just 6 inches of rain, 149 millimeters, fell on up to 12 inches of snow, so a maximum of 15 inches of rain if melted, over a 3-month period. The flooding, which inundated nearly all the main rivers in the south, Midlands, and the northeast of England, was notable for its origins, geographical extent, and duration. Impacting on 30 out of the 40 English counties over a 2-week period, when around 700,000 acres of land became flooded. Tens of thousands of people were temporarily displaced from their homes, and thousands of acres of crops were lost, and this was just 15 of the estimated equivalent 98,425 inches of water that was shed on the British landscape after the last ice age. This is the reason that rivers, like the Thames, still flow even after months of drought, as the groundwater is constantly leaking into the river, which was at its highest rate at the start of the Mesolithic, just after the great meltwater floods. Sea level changes. If this model is correct, we should be able to get verification, via other empirical evidence as shown in sea level water rises, to see if it has been constant over the last 12,500 years. Most geologists and paleoclimatologists, when talking about the end of the last ice age, refer people to the phenomenon called the meltwater pulse, which is the rapid rise in sea level, 20 meters, between 13,500 and 14,700 years before present, over a 400 to 500 year period. Although it is a tremendous value, it should be recognized that this pulse is only 16% of the total sea rise since the end of the last ice age. We have constructed a model of sea level changes, by combining both the Warden Sea model and the NASA sea level model, to calculate the rise in sea level in the North Sea area, and the discharge levels from the rivers that flow into the area over the last 10,000 years, since the last ice age. When we put all the information about the Holocene together, including the vast amounts of meltwater, ice melt pulses, raised water table and increased precipitation, then we are left with evidence of increased water activity, volume and consequential levels of Holocene rivers. We have also added the increased precipitation during this period to our graph to indicate the reasons for the river flooding events. Therefore, the blue discharge line on the graph is an indication of the volume discharge and hence the size and height of rivers over the last 10,000 years. The chart uses today's discharge rate, which represents 1 unit of river flow. This gives us a simple visual comparison to previous years, as a ratio of size. Hence 8050 BCE, the rivers were 140 times larger than today. You have been watching a small part of the Prehistoric Britain DVD documentary called The Stonehenge Enigma. The full 3-hour DVD is available on Amazon as well as all 3 trilogy books.